The next about gases. What is a gas? It is defined as the form of matter which possesses fluidity, but it is highly compressible and hence has neither definite shape nor definite volume. Solids have definite shape, definite volume. Liquids have a definite volume but not definite shape because it takes the shape of container. But the gases are the form of matter which possesses the fluidity. It also flows, but they are highly compressible. Liquids also little compressible, we cannot say that, but gases are highly compressible compared to the liquids, and hence has neither definite shape nor definite volume. If you take an example of a balloon, uh, if you take air from the balloon and if you pass that air into another balloon, can we say that exactly how much amount of air if you blown from the one balloon to another balloon will be the same? No, we cannot say that because it doesn't have a fixed volume, or even it doesn't have a fixed shape also. So gases neither have a definite shape nor definite volume. Why? Because the gases do not have a definite shape or definite volume, but acquire the shape of the vessel in which they are placed. The volume of gas is equal to the volume of the container. If you blow the volume in different shapes of balloons, we will get different shapes. But we cannot say that it is a fixed shape of gas. We can feel it only, but we will not get any shape of gas. Next point is gases have a maximum fluidity and least rigidity. It's very important. Gases have maximum fluidity. Fluidity means it will flow like liquid, and least rigidity. Rigidity means it is not hard as like solid. Due to large interparticle spaces, here interparticle spaces in solids are more, and in gases here if one particle, here another particle, here another particle. So interparticle distances are more here. So due to this large interparticle spaces, um, or weak interparticle force of attraction, gases have high fluidity and least rigidity. Next point, gases are highly compressible. See, if you take an injection, or just I will tell you an activity, you take an injection and remove the needle from that and try to compress by adding water in that. Can you able to compress that injection? Take air and try to compress that? No. But uh, by holding the finger in front of that nib and try to compress, yes, we can compress easily. And even balloon also we can compress at maximum extent. If we compress more, it bursts out. Means gases can be compressible, but liquid cannot. I told you, even 1 liter water bottle, if you try to compress, only the volume, its shape changes, but it will not compress. Since interparticle spaces here, since interparticle spaces in the gaseous state, once again, okay, since interparticle spaces in the gaseous state are very large, they can be decreased by applying pressure. Very important point, just notice here. So interparticle spaces in the gases are very large, so they can be decreased by applying pressure. I told you, if you balloon, if you compress and compress, you can compress at a large extent, at last extent, at maximum extent. If you some more point, if you compress more, it will burst out. So till the burst out, there will be chances of compression. Thus, a gas can be easily compressed by applying pressure. In other words, gases are highly compressible. So due to this high compressibility, large volume of gas can be compressed into a small cylinder and transported easily. That's why what we are using nowadays, the LPGs, which is called liquefied petroleum gas. It is not liquid petroleum gas, liquefied petroleum gas. Why we will call it liquefied? Because we are converting the liquid gas into liquid into gaseous form. Means even we do know that we are using oxygen directly, but how the peoples which are affecting in hospitals, how they use oxygen? Can they come outside and they will take oxygen directly? No. We will provide them oxygen from the gaseous state into liquid state. Means we can compress the gas from the gaseous state into liquid state. See, LPG, usually liquefied petroleum gas, why we will call it liquefied? Because we have converted them from liquid to gaseous state. Then that's why we are using that LPG in cooking. And oxygen cylinders which are using in hospitals, they are nothing but it is compressed oxygen, so that the persons who are unable to take oxygen directly from the environment, the doctors will provide them oxygen in the form of liquid. They will be compressed and they will provide them for patients. And even CNG, compressed natural gas, which are used in the vehicles, autos and all, they are run by CNGs. Okay, next, gases have low density. As compared to solids and liquids, gases have low density. This is because gases have large interparticle distances. Gases density of the gases is very low as compared to the solid and liquid, because interparticle distances are more. Due to this more interparticle spaces, it have low density. As I told you in previous classes, if you hit with a stone, you will get a pain, or if you hit with a water bottle or water, you will get little pain. But if you hit with a balloon, will not get any pain, because the density of that balloon is low, where only small interparticle spaces, large interparticle spaces are there, and that will be quite small. Okay, and there will not getting any large interparticle or particles will be found in that. Next one. Fifth one, the kinetic energy of the particles in the gaseous state is high. It's a very important point. Remember everyone. The kinetic energy of the particles, as we discussed about the kinetic energy in a previous class, students. Can I remember the definition of kinetic energy? Anybody? What is kinetic energy? Kinetic energy is nothing but the energy possessed by the particles due to its motion. When the particle possesses energy due to the motion, that will call as kinetic energy. See here, due to large interparticle distances and weak force of attraction, the particles of gas can move freely, and it can possess the energy, and thus have large rotational and vibrational motion due to the kinetic energy is quite high. Means the gaseous particle can possess the kinetic energy more compared to the solids and liquids. See, due to the large interparticle spaces, the particle, see, as this is moving laser, it can move very fast in a gaseous, but in a solid and liquid, it is not able to move, because there is no any vibrational. Only solids will get vibrational, but here the vibrational motion is very large. That's why where the vibrational energy is very large and rotational motion is very large, in that the kinetic energy will be the maximum. So here gases will get kinetic energy more. And a sixth point, gases exert pressure. When we blow air into a balloon, the air particles collide with the walls of the balloon and exert pressure on them. This air pressure causes balloon to inflate, or like even when we take air inside our body, the air traps inside our lungs, and the alveoli get expanded. So same we can even do experiments. I think you done in a previous biology experiments about the respiration. When you blown air, as the balloon inflates, expands. Inflate means expands. So it expands because the air particles collides with the walls of the balloon and exerts pressure on them. So because of the pressure of the particles in the balloon, it causes the balloon to increase its size. Okay, next, seventh point. Gases diffuse very rapidly. The particle of one gas can readily moves into the space between the particles of the other gas. This spontaneous intermixing of gases is called diffusion. Thus, gases diffuses very rapidly. I told you about the diffusion in previous class, previous concept. One particle can easily diffuse into another particle. So this spontaneous movement or intermixing will call as diffusion. So gases will show the diffusion very rapidly. And here the characteristics of